Hello. This is a tutorial which is a part of an assignment in a software hardware co-design course. In this tutorial, we are going to create a hardware design with the Vivado IP integrator for the Zibo board. Our objectives is to create a hardware design in which we will use the AXI GPIO to connect the onboard LEDs, switches and buttons to the base design, and later we will import this hardware into the SDK and we will create a SQL project to access and connect these LEDs and onboard switch and buttons together so we can see how this thing can work and can be used in the hardware and software co-design. What do we need for creating this project is to have installed a Vivado and a Xilinx SDK, and on the hardware part we need a Zibo board with a USB cable. So for the first part we need to create the hardware based design in the Vivado. In order to do that, we will launch Vivado, and after the software start running, we can go to create a project. Next, we can specify name for the project, like next. At this point, we don't need to specify any source or constraint. Therefore, we will tick this option and click next. After that, we go to the boards, and here we'll type Zibo. This is our target, and finish. Okay, from here in the IP integrator, we go to create block design. You can assign any name, but I will go with the default. So, in the diagram, you can click this plus button, or just right click and add IP, which both has the same function. The first thing that we need to add is the Zinc processing system. Double click, and it will be added automatically. The next step is to run the block automation. We'll keep everything by the default. Okay. So at this point, your design should look like this. Next step is to right click, add IP. At this point, we want to connect the GPIO. We just search GPIO and we have the AXI GPIO. We can double click on the AXI GPIO 0, and in the IP configuration we should enable dual channels. We need another AXI GPIO because we are going to use this one of the GPIOs for the buttons and the other one for the LED, for the switches, and another AXI GPIO just for the LEDs. Okay, and then we need to run run connection automation. Click all of them, select them. First we go to the GPIO 0. GPIO. This one will be connected to the buttons. It's good. Next one, we will connect this to the switch. And on the AXI GPIO 1, we will connect this board to the LED. Click OK. Okay. At this point, Vivado has added the AXI interconnect to the all design, and also the processor system reset, and also the board parts, which are the buttons, switch, and LED. So we need to regenerate this. Okay, now we can see it much better. As you can see, buttons and switches are connected to GPIO here, to the GPIO 0, and LED is connected to the GPIO 1. So everything looks perfect. We will go to the next step, which is validating the design, which is this button. If everything was followed properly, we will go to this step, which validation successful. Okay. After this step, we need to go to the source, and here we will right click, create HDL wrapper. We go with the let Vivado manage wrapper and auto update. Okay, at this step, Vivado is creating the HDL wrapper, which is a VHDL code for our design. We don't need to know the detail, it's okay. The next step is to generate the bit stream, which is here. Actually, we need to run the synthesis and run the implementation, then generate the bit stream. But by pressing the generate bit stream, all the steps from here to here to here will be done automatically. And click OK. Okay, this will take a while, might take like 5 or 10 minutes. I will pause the video by now, and the next part will start after we will create the bit stream.